Hello children, today we are going to discuss chapter acid, bases and salts. This is second chapter of NCERT book of class 10. Let's know what are acids. As you already know that we have discussed in class 7 already, acids are sour in taste. They can turn blue litmus to red. Acids are things which are present around you like lemon. We are having acetic acid around us in the form of vinegar. These are things which are sour in taste and they can furnish H positive ions in aqueous solution. When you will dissolve any acid in water, it can give you H positive ions. They can corrode metals. Acids, when reacts with metals, they can liberate hydrogen gas. Most of the metals reacts with acids to liberate hydrogen gas and it causes its corrosion. Examples are we are having two major types of acids, strong acids and weak acids. Strong acids are hydrochloric acid, sulfuric acid. Strong acids are those which can dissociate almost completely in aqueous solution. Weak acids, acetic acid, oxalic acid, citric acids, they can't dissociate completely in aqueous solution. Concentrated acids are those in which concentration of acid is more and water is less. And dilute acids are those in which concentration of water is more and of acid is less. We can dilute an acid which is given to you in the form of concentrated. You can take water and add acid in it drop by drop with constant stirring to make it dilute acid. Then we have bases. Bases are bitter in taste. They can turn red litmus to blue. They can give OH negative ions in aqueous solution. They are soapy in touch. Things around us like we are having washing powder, washing soda. These are bitter in taste and they are bases. We have strong bases and weak bases. Strong bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, and weak bases are ammonium hydroxide, aluminium hydroxide. These are things which can't almost completely dissociate in aqueous medium. Alkalis is the word used for water-soluble bases. Like sodium hydroxide, you can dissolve in water, then it is called alkali. Then we have indicators. Indicators are the substances which can give characteristic color or smell in different types of substances. Like we can distinguish between acids and bases with the help of different indicators. You must have seen a stain of curry on your clothes which gives you yellow color. When we wash it with soapy water, it gives you reddish orange color, which will again go back when you will make it dry in the presence of sun. That is example of indicator. Turmeric powder can be used as indicator. It gives you reddish color in presence of base, soapy solution. We have natural indicator, we have artificial indicators. Natural indicators are those which you can get from nature. We are getting them from plants like we have litmus. Litmus in presence of acid will be red and in presence of bases it will be blue. Turmeric solution. Turmeric solution is in presence of acid it is yellow and in presence of bases it is red. Litmus solution you can get from lichens. They were already purple in color. When they reacted with acids and bases, they gives you red and blue color respectively. Then we have synthetic indicators. Synthetic indicators are chemical substances. They also give you different types of colors in acidic and basic medium. Like we have methylene orange, we have phenolphthalein. Methylene orange in presence of acid is red, in presence of base it is yellow. Phenolphthalein in acid is colorless and in bases it is dark pink in color. This is indicator which we are using in titrations. Then we have olfactory indicators. Olfactory indicators are giving you different smells in acidic and basic mediums. But olfactory indicators always are not reliable. Sometimes they give you reliable results. On the other times, when they are not used properly, they will give you different smells which are not expected. Like in case of vanilla essence, in acids its smell increases or retains. In clove oils also its smell retains, but in bases its smell decreases. Both cases, vanilla as well as clove oil. Then we have chemical reactions of acids and bases. Acids, when reacts with metals like zinc granules you are taking and adding HCl in it, it will give you zinc chloride plus hydrogen. Hydrogen gas will start coming out when you bring a burning matchstick near the mouth of test tube. It burns with popping sound. If you want to experience this activity, you can go on our channel and you can get this video of popping sound. You can see there burning of a reaction of zinc with HCl. Then NaOH reacts with zinc metal. It gives you sodium zincate along with hydrogen gas. This is again same type of reaction in presence of acids and bases. When zinc granules are reacting with acids and bases, both are liberating out hydrogen gas. But in case of acids, this reaction will be quite fast as compared to bases. This is reaction, how you can perform. You are taking a test tube, you are taking zinc granules in it, adding acid in it, liberating out hydrogen gas. You can collect this hydrogen gas under the soap solution. When bubbles will start coming out, you can bring a burning matchstick near the mouth of test tube. It will burn with popping sound. Popping sound is confirmation of hydrogen gas. Then we have reactions of metal carbonates and metal hydrogen carbonates with acids. First, we are taking sodium carbonate and reacting it with HCl. Let's see how we can learn this reaction. Write it in this way. We are having Na2CO3. Na2, out of CO3, CO2, carbon dioxide gas will liberate out, leaving behind one oxygen atom. And along with this, we are taking two HCl molecules. Now see how they will react. It will give you NaCl. This will also give you NaCl. So you are getting two molecules of NaCl. This is H2O. One water molecule, and this is CO2, carbon dioxide. In this way, you can remember it will give you salt plus carbon dioxide plus water. Similarly, if you are taking sodium hydrogen carbonate, reacting it with HCl, you can write it in this way. It is NaHO CO2, then HCl. It will give you NaCl, water, and carbon dioxide. Means what you have to keep in mind whenever you are taking metal carbonate or metal hydrogen carbonate, reacting it with acid, they will furnish carbon dioxide gas, water along with salt of that particular metal. If you want to test whether carbon dioxide gas is coming out, how you can test? You can pass this carbon dioxide gas through lime water. It will turn it milky. Carbon dioxide gas, when react with lime water, it will react like this. It will give you CaOH twice. React it with carbon dioxide. They will give you CaCO3 plus water. Calcium carbonate plus water. It will turn your lime water milky. Milkiness is confirmation of carbon dioxide gas. But if carbon dioxide gas is passed for long time, then this milkiness disappears. It will give you calcium carbonate, carbon dioxide plus water combines to form calcium hydrogen carbonate. Again, write it in this way, CaCO3 then CO2 H2O. See, they are making CaHCO3. H and CO3, this is HCO3, right? This is one unit of HCO3. This is another unit of HCO3. They are combining with calcium to form CaHCO3. That is calcium hydrogen carbonate. It is written here wrong. It is CaHCO3 twice. Please make the necessary correction. Then acid plus base, when they combine with each other, they are giving you neutralization reaction. HCl plus NaOH. It is giving you again NaCl salt plus water. It is NaCl plus H2O. It is NaCl plus water. What is neutralization reaction? When acid and base, they are combining together, they are giving you neutralization reaction. For performing this activity, neutralization reaction, what we can do, we can take the 20 ml of given acid in a test tube and add 2 drops of phenolphthalein in it. Phenolphthalein in acidic medium will be colorless, right? After that, start adding base in it drop by drop. At one particular point, you will get light pink color. That is end point of this titration. At that point, you have to stop and you have to check the quantity, that how much amount of base has been consumed by acid. At that point, reaction will be complete. Then you can stop it and you can check the concentration of given acid, which was unknown to you. Then reaction of metallic oxide with acids. Metallic oxide like calcium oxide reacts with HCl to form calcium chloride plus water. We are having here CaO reacting it with HCl. Two units of HCl we are taking. They are combining together to form H2O, water, and this is making CaCl2. Then reaction of non-metallic oxide with bases. Non-metallic oxides, carbon dioxide reacts with base, calcium hydroxide. This is same reaction we have done just now. It is giving you calcium carbonate plus water. This first reaction we have done as confirmatory test for carbon dioxide gas. What do acids and bases have in common? All acids have H positive ions. These H positive ions are responsible for their acidic characters. All bases have OH negative ions. These OH negative ions are responsible for their basic character. Acids and bases, when they react in water, what happens? Acids give H positive ions in presence of water. Water will combine with that to release out H3O positive hydronium ion. HCl, when react with water, it forms H3O positive plus Cl negative. Bases when dissolve in water gives OH negative ions. Like NaOH gives you Na positive, OH negative. What is universal indicator? It is mixture of several indicators. It shows different colors in different concentrations of acids. pH paper you must have seen. pH paper gives you different colors in presence of different acids and bases. In presence of strong acids, it is red in color. In presence of weak acid, it will start turning to orange. Then in the presence of bases, universal indicator is blue in color. In presence of neutral substances, it is greenish blue, green. Then it is turning to blue. pH is very important in everyday life. Our body works at optimum pH range of 7 to 7.8. If our stomach is getting upset due to more acidity, that is because of decreasing pH of your stomach. You will feel the problem. Then you have to take some antacids. Then pH of rainwater, if it is less than 5.6, it is called acid rain. Now from where this acid will come? From burning of coal, you are getting sulfur. Sulfur, when combines with oxygen, it forms sulfur dioxide, sulfur trioxide. These gases, when combines with water, they form sulfurous acid, sulfuric acid. Similarly, from vehicle emission, you are getting nitrogen dioxide, NO2. NO2, when combines with rainwater, it forms nitric acid. These acids and bases, these acids are responsible for acid rain. This acid rain, when falls on Taj Mahal, on buildings made up of marble, then these buildings are getting corroded. That is also called as marble cancer. Means it is getting destroyed because of that. Similar effects can be seen on different types of crops, on even human body. Then our stomach is producing HCl. If it is releasing more HCl, you are getting acidity because of untimely eating. Sometimes we are not eating on proper time, or sometimes we are not eating for long time, or too much eating. These can be causes of acidity. If acid is produced by our stomach in much quantity, then you have to consume some antacids. Antacids can be like we have magnesium hydroxide, we can have we can have that gelocin. These can be the things which you can consume as antacids. Even water added in milk can be taken to reduce the acidity. Tooth decay starts when pH of our mouth is less than 5.5 due to consumption of too much sugary substances. If you are taking too much of the chocolate, if you are taking too much of the sugary things, or you are taking too much of the cold drinks, soft drinks, that all will cause tooth decay. Plants need specific pH for their healthy growth. If they are having too much acidic or basic pH, that will ruin the crops. Then animals, they are causing self-defense by using their pH, like in strings of certain insects, there is methanoic acid. That methanoic acid, when injected in our body, it is painful condition. So we have to use some base. We have to apply some base over it to neutralize it. Salt is formed by neutralization of acid and base. You must have heard about Gandhiji's Dandi March, in which he has prepared salt by breaking the salt rule made by Britishers. What we did to make the salt from seawater, by doing the process of evaporation, we are getting raw salt. Then we need to purify it by using process of crystallization. In crystallization, we are taking impure salt, we are dissolving it in water, then we are filtering it, making its concentrated solution, keeping it undisturbed for a day. Next day, you will find crystals of sodium chloride settle down. In mother liquid, there will be impurities that can be taken off to get the pure salt. We can dry the crystals to get the pure crystals of sodium chloride. Different salts are different salts from where chemicals different chemicals from where salts can be obtained are sodium hydroxide, bleaching powder, calcium oxychloride, sodium hydrogen carbonate, sodium carbonate as washing soda, then plaster of Paris, CaSO4 dot half H2. This is half H2. This is half H2O, CaSO4 dot half H2O. Chemicals from common salt. Sodium hydroxide. NaOH you can get by reaction of NaCl with water. This process is called chlor-alkali process. Now let's discuss this process in detail. This is most important reaction you can get from this topic. NaCl will further break down to form Na positive and Cl negative ions. Water will break up to form H positive and OH negative ions. Out of Na positive and H positive will reach fast at cathode, H positive will reach at cathode, will gain electron and give you H. Two atoms of hydrogen will combine together to form hydrogen gas. Out of Cl negative and OH negative. Out of Cl negative and OH negative, what will reach fast at anode? Cl negative. Cl negative will lose electron and turn to Cl. Two atoms of chlorine will combine together to form chlorine gas, Cl2. So you will get hydrogen gas and chlorine gas remaining behind NaOH in the solution. NaOH, sodium hydroxide, also known as caustic, can be used to make soaps and detergents. It is used in paper manufacturing. It is used in oil refining. It is used for preparing PVC sheets. It is also used to make pesticides. Second is calcium oxychloride. Calcium oxychloride is also known as bleaching powder. This is prepared by the reaction of calcium hydroxide with chlorine. See how? CaOH twice. It is combining with chlorine. So you will get CaOCl2. Calcium oxychloride plus water. This is H2O. Bleaching powder is used in different types of industries. Purpose of using this is It can bleach the substances, it can bleach the colored things, and it can make the things colorless. It is used in textile industries. Sometimes when we are getting dupattas decolorized, that is with the help of this bleaching powder. Then wood pulp can be bleached with the help of bleaching powder. In sugar industry also we are using this bleaching powder to bleach the sugar solution. It is used as oxidizing agent. It can provide nascent oxygen. Nascent oxygen we are writing like this in bars as it is very reactive. Nascent oxygen, when combines with any colored substance, it gives you colorless things. It is used to disinfect water. It is used to kill the germs present in water. Then we have NaHCO3. It is baking soda. Baking soda is prepared by the reaction of sodium chloride with water, carbon dioxide, and ammonia. This reaction can be explained like this. We are having NaCl, then you have H2O, then carbon dioxide and ammonia. This is NH3. So it will give you NaHCO3 and it is NH4Cl, ammonium chloride. NaHCO3 is baking soda. Baking soda is mild corrosive base. It is when it is heated during cooking, it furnishes carbon dioxide gas. This carbon dioxide gas, when coming out through your batter, it needs some spaces. So these spaces will make your cake fluffy. It is used as antacid. It is used in fire extinguishers. For making baking powder, we need to add tartaric acid. We need to add certain edible acids in it, which can neutralize its bitter effect. Because if you are using only baking soda, your cake will be bitter in taste. So we need to use baking powder along with baking soda to neutralize the effect of this bitterness. Baking powder is used in baking industry to make the things fluffy and crispy. Then we have washing soda. Washing soda is sodium carbonate decahydrate. It is having 10 water molecules as water of crystallization. Water of crystallization means number of water molecules that are loosely bound with a compound that it can liberate when it is released free. When you will keep it in sunlight, these water molecules will evaporate. Sodium carbonate plus water gives you Na2CO3 plus dot 10H2O. It is 10 water molecules as water of crystallization. Washing soda is used in laundry. It is used in glass, soap and paper industry. It is used to manufacture borax. It is used as cleansing agent at houses. It is also used to remove hardness of water. Water is hard because of presence of calcium and magnesium ions in it. If you are having calcium and magnesium, chlorides and sulfates, it is called permanent hardness of water. If water is having only carbonates or hydrogen carbonates, then it is temporary hardness. Temporary hardness can be removed by just boiling. You will boil the solution and its temporary hardness can be removed. But if it is having this permanent hardness, you can't remove it by boiling. In that case, we need to use ion exchanger. In ion exchanger, we will exchange calcium ion by sodium ion. In that, we are using it sodium carbonate to remove the permanent hardness of water. Then we have plaster of Paris. Plaster of Paris is CaSO4 dot half H2O. CaSO4 dot half H2O, when it is mixed with water, it will give you calcium sulfate dot 2H2O, means it is giving you POP. Here it is 1.5 water molecule. It is 1.5 water molecule that is added to give you calcium sulfate dihydrate. It is gypsum. Plaster of Paris is used in fractured bone to give them support. It is used to make toys or decoration material. It is used to make the surface smooth in our down ceiling. We are using POP. That's all about this chapter. Thank you.